Hello and welcome to this session. So in this session we're going to be talking about the difference between subnets and VLANs. We talked about subnets in the previous video, so if you haven't watched that, kindly go to the video, watch it, and then maybe come back to this one, or you can watch this one first and then go back to the subnetting video. But anyways, we're going to go through the basics of both concepts and get to understand how each plays a role and what is the difference between the two. So if you're into this kind of content, remember to hit the like button, comment down below, and also subscribe to my channel so that you're updated each time I upload a new video. So let's get into subnets and VLANs. So as we might all know, both subnets and VLANs, or virtual local area networks, are used to scale or separate network traffic. And when we are talking about subnets, we said that we are talking about physical networks, and this means that you have to deploy different physical devices in order to achieve the subnetting part of it. And when you're talking about virtual local area networks, we are talking about virtual networks, and this basically means that you have just one network, but in this one network you are dividing it into different departments or different we can call them chunks or different parts. Okay, so virtual local area networks, you have one network and you are dividing it into different departments or parts, but in subnetting we talk about physical devices or physical routers. When you do the calculation for the network address, you have to assign it to a physical router, but for virtual local area networks, you assign that to a virtual network or a department in the network that you already have. Now let's talk about subnets for a short while, though we talked about this in the previous video. Subnets is a short form for subnetworks, and this means small networks within a network, and we achieve subnetting by taking extra host bits or networking bits in the network subnet mask. The extra bits are used to accommodate the number of networks that is in classless interdomain routing, and in variable length subnet mask we take the host bits that we need to take or subdivide or work with, so that we achieve subnetting. So that's it when it comes to subnets. For more details, kindly go to the subnetting video and then come back to this one. Now let's get into the topic of the day, and that is virtual local area networks. That is VLANs, short form for virtual local area networks, and this basically helps us to divide the one large broadcast domain into several logical broadcast domains. And what this means is that we are dividing the traffic of one network into smaller traffics or smaller data traffics that are in this one network, and this is done in order to separate traffic on a specific interface by tagging or naming the traffic according to their VLANs. So what you basically do is go assign these VLANs a number, a name, and then you can be able to differentiate the traffic on the wire through the tags or the names that you give to these different virtual local area networks. So if there is traffic in the wire, then you're going to differentiate them, and we use virtual local area networks to differentiate this traffic. Now these virtual local area networks is only available in VLAN enabled switches. So when you're purchasing your switches for either home or enterprise applications, kindly consider to check the properties or the features of that device that you're buying, in this case the switch, and you should always go for a VLAN enabled switch. Now, we achieve VLANs by configuring an interface to identify frames from different VLANs, and an interface is a path through which network traffic can pass through or go through, and VLANs can be named by service department or by application. This means that you can have a voiced VLAN, you can have a management VLAN, you can have the normal data VLAN, and we're going to look at these as we go on. Now, let's look at the types of VLANs that we can have, and the first type we are going to look at it through the types of VLAN we can achieve by the type of service that we want this VLAN to serve. We have what is called as the default VLAN, and this is created whenever you log in into a switch or you power on a switch, and this is could be used as a data VLAN, as your normal day-to-day data traffic VLAN, or as your management VLAN. And we have what we call as the native VLAN, and this is used for untagged traffic. So in case untagged traffic or traffic that has not been identified through its VLAN gets into the wire, then the native VLAN is supposed to take care of that. We have what you call as the voice VLAN, and that is self-explanatory. That is used to transport voice data. If you haven't watched the voice over IP video, kindly go back to the voice over IP video, then you can understand how we create these voice VLANs. Now, types of VLANs according to the IDs or the numbers that you can give to these different VLANs. We have two types. We have the normal VLAN that range from VLAN 1 to VLAN 1005, and these are basically the normal VLANs that you would need for your corporate use or a enterprise use, and you could have a maximum of 1005 or to say 1000, yeah, it's 1005 different VLANs in your network. We also have what you call as the extended VLAN, and these are basically provide more space. If you have more VLANs in your network and you need to accommodate them, then you're basically going to use the values from 1006 to 4094. That those are the values for the extended VLAN. Now, on physical devices, we have to note this: only one VLAN can be active, and that means that the protocol changes to up if there is an active connection to the VLAN. So if you have different VLANs in your network, then in physical devices only one VLAN can be up, and it's going to be up if there is an active connection to that particular VLAN. So as we assign VLANs, we also need to assign an interface range for different VLANs, and these are going to basically serve the different VLANs that you have. You could have VLAN 1 taking the port numbers from interface 1 to interface 6. Then you could have VLAN 20 taking over from interface 7 to interface 16, and so on and so forth, according to the number of ports or interfaces that you have available in your switch. Now, an interface, as we said earlier, is the path or a port through which network traffic passes, and you have different types of interfaces when you are assigning a VLAN interfaces. We have an access interface, and this is an interface or a path that uses a VLAN ID to identify frames and only allows frames from one VLAN to pass through. So when you are configuring these VLANs, there are three modes that you could set them to, and one of them is the access interface, and this only allows one VLAN to use that specific interface, or only traffic from one VLAN can be used to travel from that specific interface. We have what we call as the trunk interface, and this allows multiple VLANs to go through it, and when I'm talking about VLANs is VLAN traffic. We also have what we call as the hybrid interface, and this is a combination of the access interface, that is, it can allow traffic from one VLAN to be transported through that interface, or it could allow multiple VLANs to use the same interface, and that changes according to demand, that is according to the active connections that you have, or that you are available in the network. Now you have to note this, that if one wants to remove a VLAN or you want to delete a VLAN, ensure that no ports are assigned to the VLAN, otherwise the ports will be inactive, and this will remain inactive until manually allocated to another VLAN. And if the ports are unassigned before erasing a VLAN, then they are taken by the default VLAN. So those are two very important concepts that you need to understand, or two things that you need to keep on reminding yourself when you're talking about creating and removing VLANs from switches. Now let us talk about how we can communicate from one VLAN to another. By default, you cannot communicate from one VLAN to another. So machines from one VLAN will only be able to communicate within themselves. But if you want these machines from different VLANs or from different departments to communicate with each other, then you need to connect a layer 3 device, and this is what we call a inter-VLAN communication. When one VLAN is talking to itself, that is what we call as intra-VLAN communication, that is traffic from one VLAN. When we are talking about multiple VLANs communicating with each other, we talk about inter-VLAN communication, and this is implemented by connecting a layer 2 switch to a layer 3 device, as we have just talked earlier. Now the communication of packets are routed through the layer 3 device, and we could have a multi-layer switch, that is a switch with the layer 2 and layer 3 capabilities, meaning that it has routing capabilities, or you could use a router. Now we use a trunk interface to allow multiple VLANs to communicate through one interface from the layer 2 device into a layer 3 device through the interface, and using the router's physical interface, or sub interfaces, which are logically separated by sub interface numbers, we implement inter-VLAN communication. Now this means that when you connect to a router, the access interface that you're going to use, or the interface that you're going to use to connect from your switch to your layer 3 device, is supposed to be a trunk interface. That means that it's going to allow traffic from multiple VLANs to pass through it. So you could have multiple switches connected to this layer 3 device, and these switches have different VLANs. Or it could be in one network you have one switch which has multiple interfaces, but you allocate, or you leave one interface from the switch to the router, and that interface is going to be a trunk interface, so that it can allow all the VLANs or the different departments in that network to communicate with each other. And when we are doing this, the port or the interface on the router is used, and we can either have multiple interfaces from the router or just one interface. Then you divide it into sub interfaces, which are logically separated by sub interface numbers, or VLAN numbers, and this will basically help you to implement inter-VLAN communication. Now different sub interfaces or interfaces, according to what you have, will have different IP addresses, and we set the different IP addresses as the default gateways for the different virtual local area networks. For example, if you had a gigabit interface, that is a gigabit 0, we're going to divide it into gigabit 0.10, that is for VLAN 10, and gigabit 0.20, that is for VLAN 20. And these two are going to have a different IP address. VLAN 10 will have an IP address of 192.168.1.10, and VLAN 20 will have 192.168.1.20. Those are going to be the different IP addresses to these VLANs, and this could be considered as the network addresses for these VLANs. And the reason for assigning IP addresses to these VLANs is that you can be able to communicate over layer 3 devices. Remember that layer 3 devices ask for IP address information in order to communicate. Now, when we have assigned these different IP addresses to the VLANs, then we use the .1q encapsulation to tag the packets according to the VLANs in order to identify or terminate packets in our sub interface. And what I'm saying here is that for you to be in a position to identify the different frames, then we, from different VLANs, we use an encapsulation, and this is a method for adding a header to a packet, and we are going to add a .1q encapsulation to the packet in order to give the different tags. If you need to tag it as VLAN 10, then that is the encapsulation that you're going to use in order to give the different VLAN names. Now, that's it when it comes to subnets and VLANs, and that is I believe you have covered the difference between the two. Thank you for joining me in this video. See you in the next video. So all the best, and peace.